Okay, so I cut my last video because you're going to need a calculator to do this one, and I'm assuming that some of you don't have calculators at home, so stopping right there and practicing that is good enough for me. So let's just rewrite this one. We're not going to plug it into a calculator, we're just going to talk about it. So this is log base 10 of 100. So I have my base of 10. I have my equal sign. I have my 100 that gets its own room. And then I'm looking for this guy up here. So 10 to what power equals 100? This should be 2. Okay, nice and easy. So then we've got some special cases. We've got the log base e, which is the same thing as natural log or ln. Okay, so we've got some properties of this and some things that like are easier than others, some things that we're going to have to memorize, some things that we'd need a calculator for. So I want to come back to you and give you this later. Okay. I do want to scroll forward into the 5.2 log functions day 2, and I just want to talk a little bit about our graphs. Okay. So log base b of x is a logarithmic function where b is greater than 0 as long as b doesn't equal 1. Okay, b is also known as the base, and you should have that memorized by now. In exponential form, the equation of this is b to the y equals x. Okay, I've been frequently leaving this as b to a box equals x. So, right here we have our base. We have our equal sign. We have the x. And then we have this box that's empty. We kind of have an empty x right now too, but that gets filled in by this chart. So this means we need to go through and we need to do a whole bunch of things here. So 2 to the negative 2, that negative sign creates a fraction. I'm going to zoom in here. I get 1 over 2 squared, which is the same thing as 1 over 4. Remember that negative sign flips it into a fraction, and it's to a first power, so it's just a 2. This one's a rule. Anything to the power of 0 is 1. This one's also a rule. Anything to the first power is itself. And then 2 squared is 4. So we go through, we get this really pretty function. Makes that J a shape. Okay. So we're going to start by graphing that exponential. And keep in mind that an exponential is an inverse. And we haven't talked a whole bunch about inverses, but inverses mean the opposite. Okay. So that means that we're going to have to graph this all over again. Okay. But I want to review that this domain is my left and right. It's my x values. And that goes left towards negative infinity. It goes right towards infinity. They always get parentheses because we don't touch that. My range, if you recall, it does not go any lower than this 0. It actually never touches this 0. That 0 is called an asymptote. And we talked about how you never touch the asymptote. Okay, I gave you a really fun way of how to remember that. And so that asymptote is at y equals 0, and that 0 affects my range. And we do not touch the 0. So that's how far down it goes. And then how far up it goes is to infinity. And again, we can never touch infinities. Infinities, like we don't know exactly where they are. My y-intercept here is a 1. It hasn't moved, it hasn't shifted. It's that 1 that anything to the power of 0 is 1. So, an inverse says, go ahead and switch those coordinates. So, where the negative 2 was in the x, it moves over to the y. And so then that 1/4 goes here instead. That 1/2 goes here instead. That 1 goes here instead. The 2 goes here instead. The 4 goes here instead. Okay. For me, I never draw both of them. I really just draw that XY chart. And instead, I just start with all of my Y's. So normally we start with all of our X's. I just start with all of my Y's. So then this graph looks like 1/4 and -2. Then 1/2 and -1. Then 0 and 1. Then 1 and 2. Then 2 and 4. Okay. So notice my 1/4 went first, then my 1/2, then my 1, 2. Notice I don't have a 3 point, then 4. Okay, so it's a little strange, it's a little wonky. But I get this graph. And on this graph, so all this has done is turned my graph, and I have an asymptote right there. But now instead of that asymptote being a y equals, it's an x equals. So my domain, how far left does it go? Well, it now no longer goes all the way to negative infinity. It has to stop at that 0. But it does go all the way to the right to infinity. Neither one of those touch, both of them get parentheses. Noticed it's just switched. If I look at my range, how far down it goes down to negative infinity. It goes up to infinity. Notice, again, my domain and range, they just switch. Okay, then notice I didn't ask you about a y-intercept anymore. This time I asked you about an x-intercept. That's because my x's and my y's are switching. I actually have no y-intercept. My y-intercept does not exist. Okay? So my x-intercept here is at that 1 point. Notice it matches. Okay? So these are really interesting. What's cool about these is that what we're talking about with the coronavirus matches up to log and exponential graphs. So we see all these things about like, oh my gosh, all these countries had this exponential like growth, and that it just kept doubling and doubling and doubling. And then we see things that say like flatten the curve. And like flattening the curve looks like these logarithmic graphs. So that's the kind of cool thing, is that this actually does relate to what you're seeing in the news right now. All of these graphs that are being created from this information right here. So that's really super cool. Like something that I told you, I didn't think that a whole lot of you would see this in your life. Like there's a lot of application to it, but you might not do a job that's involved in it. You're seeing them every day. If you're watching the news, you see a graph of this. If you're looking at social media, you're seeing a graph of this. So that's pretty cool. Okay. So log 4 of x. I want to just practice that we're moving it. I know I already give it to you, but I want to practice it. So it's a base 4. It's going to equal that x. And then I have that box right there, that's the y. So for me, I never fill this out. This is extra information that a lot of teachers give because they want you to see how they're inverses of each other. For me, I think that you're just putting down the same information twice. I don't believe in that. Like, I want to see you just do it. So we have those x's and y's. Normally, we always start with x's, but because it's an inverse, we're going to start with y's. So we need to know what's 4 to the negative 2. It creates a fraction. 4 squared is 16. The negative creates a fraction. 4 to the first is 4. Anything to the power of 0 is 1. 4 to the first is 4. 4 to the second is 16. And then don't forget that there's that like mirroring pattern there. So like 16 and 1/16, 4 and 1/4, stuff like that. So my domain here. This goes we can't do this until we graph it. Okay, so I'm looking at 1/16, hard to graph. 1/4, hard to graph. 1, not hard to graph. So I'm going to go to 1, 0. I'm going to go to 4, 1. I'm going to pretend I go all the way to 16 and go up to 2. So I've got this thing going on right here. It kind of looks linear, but it's not. It's a flattened curve. And then remember that I said like, oh, 1/4 is kind of hard to graph. Well, let's try it. So 1/4 is right about there, and it lands at -1. So I end up with that L-ish shape, that L-ish J-ish shape. And don't forget that this never crosses that line. Okay, so I always create an asymptote right here on that axis. Even though that axis is the y-axis, it is an asymptote called x equals 0, because my x's never change there, it's my y's that do. So my x-intercept is 1. My range, this goes from -infinity to infinity. My domain goes from 0, because of that 0, to infinity. Okay. So even though I don't do both of these things, what I do want to do is I want to make sure that you can, in fact, graph this, and you do, in fact, know the information for that exponential. So I want you to go through and do that entire problem on that graph. And then I think I've probably talked enough for today, so I'm going to leave the rest of this for you.